The Designed Forge control is a workflow management system, PORS, that has been specifically designed, PORS, to graphically support the entire workflow within Polarion. PORS, it's all about to make derivations that are systematic and meet specific derivation rules and quality standards. At the beginning of a Design Forge control, you define a process or even multiple processes, for example, like this one here on the screen. Within the process, you define work item types, like a requirement here, perhaps with specific filter criteria, such as a certain status. And within the scope of these requirements, we define content rules that are subsequently employed as prompts for the artificial intelligence to perform quality checks. Additionally, we establish derivation rules that are then utilized to ascertain whether the work item's derivation has been accurately completed. Once the process has been clearly defined, the next step is to move on to the task assignment. For this purpose, we use the dispatch modal. That is a window that it lists the work items that correspond to the specified input criteria and also the various users who are currently available, and then it assigns these work items to what are referred to as worksheets. A worksheet is also a special diagram that contains a specific quantity of incoming work items for a user to process. It's essentially like a work order or a job sheet. You can create multiple worksheets so that these, for example, represent sprints or specific work steps, and you assign the work to the worksheets by drag and drop, and then you can also see which work is assigned to whom, which they are meant to complete. Once the work is assigned, you then work directly within the worksheet itself. To do this, you navigate to the work mode section of the worksheet where you can clearly see all your incoming work items. You then simply click on them and checks whether they have already been correctly derived according to the process. This is possible in the tree or block diagram view. And here you can now see what the derivation is. These indicators show the assessment in quality or derivation, so you can always see if your work is far enough along and if the derivation is complete. You can set these indicators manually through a corresponding manual input here, or you can have the AI do the assessment. These work items here are red because they are in accordance with a specific regulation, the so-called color codes. Color codes can be defined for all sorts of different purposes. Any number of rules are possible. For example, here's one rule that says if the father is younger than the son, then the content should be filled in red. That's typically what we call a suspect link, because the father was changed but the sons were not checked. When you make such a derivation, you go through the work items individually, and then, for example, when you start with the new work item or this requirement, you can either manually add a child or search for existing work items that meet the input criteria, and to assign one of them where you say that this fits here as a derivation that has something to do with it here. Another option is to let the AI do the derivation, but you'd only do that once you've optimized the work item a bit. The text here is a bit thin, a bit sparse, so I'll first call optimize. This person is now giving me specific suggestions on how to better derive the work item. Now the work item is better described, and I'll review the rules again, how the derivation is specified. So my system engineering management plan is accessible at any time for a specific work item. And now I tell the AI to suggest things to me. So how should this work item be derived? For this, the AI takes the process specifications, if applicable, the context that one has specified with Polarion documents or input documents or internet links, and checks how the derivation could best be done. She's now proposing 3 functions. And I accept the 3. And I now have 3 work items here, which have been derived accordingly. The derivation process is not yet complete, because the process specifies that functional exchanges must also be provided. Nevertheless, I will now have this entire tree evaluated. So I'll mark this work item and let the AI evaluate the work items overall to see how far my work progress is according to process specifications. The quality appears to be quite good. The quality rating for this specific work item is currently only at a 2. This means it is still not considered to be sufficient. And in all these cases, the derivation is still perceived as being too weak because the requirement that is present here was not completely derived. This means we would need to perform further iterations, either with AI or through manual derivation. This is how one proceeds. All elements of the worksheet are reviewed until the derivation's completeness is good. The manager of the team or department can view all worksheets and the derivations made so far in a status overview, as well as the quality score and the derivation score. So, on the one hand, for each process, and there are various processes running concurrently here, he can see which worksheets exist there, what work items are contained within them, and how well they are derived. Which worksheet is still active. Or it can go through the users and check which worksheet each user has and how far they have progressed with it. This strictly monitored derivation and also the quality monitoring is helpful, for example, when one needs to derive and verify precise specifications in EN50 126 processes, specifically Senelec processes. The results of the worksheet are always displayed in the diagram and can therefore, for example, also be embedded in live docs.